going to be doing two different math problems. The first is Jacob had some Tiger tickets. His teacher gave him 6 more. Now he has 14 Tiger tickets. How many Tiger tickets did he have to start with? So this is a join problem. And I don't want you to get confused just because it has the word join in it. We're going to be doing some subtraction to solve this problem. So we know that Jacob now has 14 Tiger tickets. And we can represent that with 1 long and 4 units, or rod, whichever your school prefers. His teacher then gives him 6 more Tiger tickets because of his behavior in the hallway. And we want to know how many he had to start with. So this is what his total is. This is how many he was given, and we want to know how many he started with. So to do that, we're going to subtract the 6 that he was given from the 14 that he has. But to do that, I need to regroup my rod into 10 units to subtract 5 and 10. So now that I have my rod regrouped, I can take 6 away, or subtract 6 from 14. Now that I've done that, I can see that we have 8 units left, which must mean that Jacob had 8 Tiger tickets to start with. And we can check our math by doing the inverse and adding those 6 Tiger tickets back to his 8. Now we'll need to regroup our 10 units back into a rod, and we can see that once again we have 14, because 14 minus 6 is 8, and 8 plus 6 is 14. Again, that was a join problem with the start unknown. Oftentimes children confuse join problems with meaning they should always have addition. But in this case, we subtracted to find what we started with because our start was unknown. Our second problem is going to be, Jacob had some Tiger tickets. He spent 5 on the prize cart. Now he has 18 Tiger tickets left. How many Tiger tickets did Jacob have to start with? So again, our start is unknown. We want to know how many he had before he spent any. So we know that he now has 18, and that he spent 5. Being that he had 18 to begin with, and he spent 5, and this is a separate problem, most students would think that you need to subtract the 5 from the 18. But being that this problem is a start unknown problem, you actually need to add the 5 tickets that he spent to the 18 that he has remaining. And when you use your number line, it's important that all of the numbers be evenly spaced, because the value between each digit is the same and needs to show that in the number line. It needs to be proportional, because there's no more distance between 3 and 4 than there are 13 and 14 or 23 and 24. Now we know that he had 18 tickets left after he spent 5. So we can start at 18 and we can increase to the right 5. 1, 2, 3, 4, 5. And that gives us 23 that he started with. We can do the inverse of this to check our work, and we can start at 23, and we can decrease or subtract by moving to the left 5 units. 1, 2, 3, 4, 5. Which brings us back to 18, which is how many he had left after he spent 1, 2, 3, 4, 5 tickets on the prize cart. This is your number line, which is a part of your linear model. And again, like I said previously, the most important part of a number line is the spacing between the digits being equal, because you don't want children to confuse the fact that if there's more space between certain numbers, they would think that that value is more. So you want to make sure that all of the spacing is even to ensure that there's no confusion with the number line. And the same when we use our set model, it's important to use the actual models that are provided because they are proportional. You wouldn't want your 10 units to be longer than your rod when you put them together, because the value is the same. And this can help alleviate misconceptions in children if the actual model matches logically with what you're doing.